this is IGCSE Math 2, notes over on distance. I'm not giving the distance formula because the distance formula is just Pythagorean theorem and rearranged. So I'm going to show you with the Pythagorean theorem how to do it. Alright, so to find the distance in between this point and this point, I need to know that the points are x and y. So my coordinates are always going to be x, comma, y. Alphabetic order if you forget. So I need to use that, but I need to use a number line also. So let's go ahead and find. So we're going to make a number line here. 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Negative 5 right there. So on this number line here, I'm going to use this to find the distance in between my 2 points. Now, before I can do that, I need to go ahead and show you what the Pythagorean theorem is. The Pythagorean theorem is a squared plus b squared equals c squared. Now, here's Pythagorean theorem, and we're going to go through and we're going to try and find for this piece right here. But we need to know that distance is always going to be positive. So since distance is going to be positive, and we know that this one right here, we need to undo the square, we're going to end up with c is equal to the positive square root of a squared plus b squared. Now, I'm going to change this for my distance formula. So it's going to be my distance is equal to the square root of whatever my x value is plus my y value, both squared, like that. So we're going to go through and actually find for each of those. Now, first thing we're going to do is we're going to find how far apart these things are, and that's going to give me that value. So first thing I'm going to do is my x's. So let's take a look at my x's. I have 2 and negative 2. So here is positive 2, here is negative 2. Now let's count. 1, 2, 3, 4. So my x value is going to be equals 4. Let me see. And then for my y value, here's my y value here. These are y values. So I have, here's my 4. So in between 4 and 5, it's just going to be 1. So the y value is 1. Now let's plug it in. I get d is equal to square root of 4 squared plus 1 squared. And I could plug that into my handy dandy calculator. So, and we have square root. Don't forget the square root. Square root of 4 squared plus 1 squared. Close right there. All that inside the square root. And I come up with 4.1. So D is about 4.1. So that's going to be the distance in between these 2 points right here. Alright, let's take a look at this next one. This next one, we just give you a graph, and you're going to have to find the distance in between the 2 points. First thing I'm going to have to do is actually figure out where each point is. So this is my x value, and this is my y value. Don't forget that the x value always goes first. So x value, so it goes over 1, 2, 3. That's going to be negative 3. The y value is up 1, 2, 3. So that point is going to be negative 3, 3. For right here for b, x value, it doesn't move left or right at all, so my x value is going to be 0. And the y value is down 1, 2, so if it's down 2, it's negative 2. So I have those coordinates there. Since I have those coordinates, I can now do it just like I did with my previous problem. So we're going to use the same number line that we have up there. So let's take a look. I have my 2 points of negative 3, 3, and my other point of 0, negative 2. So let's take a look. How far is negative 3 away from 0? Here's negative 3 right here. How far it is away from 0. So starting here, I'd count 1, 2, 3. So d equals square root of 3 squared plus, now do the same thing for this. How far is 3 away from negative 2? Let's see. Right here. Here's 3. We're going to count to negative 2. 1, 2, 3, 4, 5. So that's going to be 5 squared there. Now we can go ahead and plug that into my handy dandy calculator. 3 squared plus 5 squared, close, and we get d is about 5.8. Okay, so now let's go ahead and take a look at a couple more examples of what we have right here. So, for the practice, you can use the same number line if you need to. So let's take a look. I'm going to add some so I could actually go all the way up to my 8 here. 6, 7, 8. Here's positive 8. 6, 7, 8, negative 8, right there. Okay, so I extended my number line so I could actually go ahead and use the same number line. You don't have to rewrite a new number line each time. So we're going to try and find the distance in between negative 5 and positive 8. Negative 5 is here, positive 8 is way over here. So it's going to be from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So right here I get d is equal to the square root of 13 squared plus, now next one's going to be 3 and negative 5. Positive 3 and negative 5. So I'm going to count backwards on this one. So from 3 to negative 5. So it's 1, 2, 3, 4, 5, 6, 7, 8. That one's going to be 8 squared. So square root 13 squared plus 8 squared, close, and I should get d is about 15.3 because that 6 makes the 2 round up. Let's take a look at my last one here. So you take a look, I go from 4 to negative 11. Let's add some numbers onto my number line so I could actually go all the way to negative 11. 9, 10. There we go. So now my number line has enough numbers here, so I don't have to redraw a new one. So how far is it from 2 to 2? So if I'm starting at 2 and I'm already at 2, that means it's not going to move at all 0. So from 2 to 2 is 0 because it's the same number. So I get d is equal to the square root of 0 squared plus, now from 4 to negative 11. 4 to negative 11. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm going to have 15 there. So d is equal to, so square root of 0 squared plus 15 squared, close, enter, and I should get 15 as my answer.